The data for our application is on a server somewhere, in the cloud, at the office, under our desk. How do we get that data into our view? Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and in this module we learn how to use HTTP with observables to retrieve data. Most Angular applications obtain data using HTTP. The application issues an HTTP GET request to a web service. That web service retrieves the data, often using a database, and returns it to the application in an HTTP response. The application then processes that data. In this module, we begin with an introduction to observables and the reactive extensions. We then examine how to send an HTTP request and map the result to an array. We add some exception handling, and we look at how to subscribe to observables to get the data for our view. We finished the first cut of a product data service in the last module, but it still has hard-coded data. Now we'll replace that hard-coded data with HTTP calls. Let's get started. Observables help us manage asynchronous data, such as data coming from a back-end service. Observables treat events as a collection. We can think of an observable as an array whose items arrive asynchronously over time. On the timeline to the left, the first marble comes in, then the second, and sometime later the third. Observables are a proposed feature for ES 2016, the next version of JavaScript. To use observables now, Angular uses a third-party library called Reactive Extensions. Don't confuse this with React, which is another thing entirely. Observables are used within Angular itself, including Angular's event system and its HTTP client service, which is why we are covering them here. Observables allow us to manipulate sets of events with operators. Operators are methods on observables that compose new observables. Each operator transforms the source observable in some way. Operators do not wait for all of the values and process them at once. Rather, operators on observables process each value as it is emitted. Some examples of operators include map, filter, take, and merge. Data sequences can take many forms, such as a response from a back-end web service, a set of system notifications, or a stream of events, such as user input. In this diagram, our stream contains 3 elements. Reactive extensions represent a data sequence as an observable sequence, commonly just called an observable. A method in our code can subscribe to an observable to receive asynchronous notifications as new data arrives. The method can then react as data is pushed to it. The method is notified when there is no more data or when an error occurs. Observables support operators, such as the map operator. The map operator allows us to transform the incoming data. The argument to the map operator is an arrow function that says to take each data item and transform it to 10 times its value. So when we receive 1, it is mapped to 10. When we receive 2, it is mapped to 20, and so on. This depiction is called a marble diagram and is helpful for visualizing observable sequences. This is a screenshot from RxMarbles at this URL. You may have worked with asynchronous data in JavaScript previously using promises. Observables are different from promises in several ways. A promise returns a single future value. An observable emits multiple asynchronous values over time. A promise is not lazy. By the time you have a promise, it's on its way to being resolved. An observable is lazy by default. Observables will not emit values until they are subscribed to. A promise is not cancelable. It is resolved or rejected, and only once. An observable can be canceled by unsubscribing. Plus, an observable supports map, filter, reduce, and similar operators. Note, however, that you can use promises instead of observables when calling HTTP in Angular if you wish. An example is provided in the Angular documentation. In this module, we'll do HTTP using observables. We often encapsulate the data access for our application into a data service that can be used by any component or other service that needs it. In the last module, we did just that, but our product data service still contains a hard-coded list of products. We instead want to send an HTTP request to get the products from a back-end web server. Angular provides an HTTP service that allows us to communicate with a back-end web server using the familiar HTTP request and response protocol. For example, we call a GET method of the HTTP service, which in turn sends a GET request to the web server. The web server response is returned from the HTTP service to our product data service as an observable. What does this look like in code? This is the product service we built in the last module, modified to retrieve the products using Angular's HTTP service. Let's walk through this code. First, we specify a URL to the products on the web server. This defines where we send our HTTP requests. Note that this URL is shown for illustration purposes only and is not a real URL. Next, we add a constructor. Recall from the last course module that we use a constructor to inject dependencies. In this case, we need Angular's HTTP service, so we inject it here. Recognize this syntax? It creates a private _HTTP variable and assigns the injected service instance to that variable. And since we are strongly typing this variable to HTTP, we import HTTP from the Angular HTTP package here. As a side note, we had mentioned earlier that in some cases the injectable decorator was optional. Now that our product service has an injected dependency, the injectable decorator is required. Recall also from the last course module that before we can inject a service in as a dependency, we need to register that service's provider with Angular's injector. The HTTP service provider registration is done for us in the HTTP module included in the Angular HTTP package. To include the features of this external package in our application, we add it to the imports array of our application's Angular module, @module. Recall that the declarations array is for declaring components, directives, and pipes that belong to this module. The imports array is for pulling in external modules. So we use the imports array to pull in this external HTTP module. Now our Angular module illustration looks like this. We declare our components. We declare the directives and pipes that those components require, and we import the external modules that we need. And for HTTP, we need HTTP module. Going back to the product service, in getProducts we use the injected HTTP service instance and call the get method, passing in the desired URL. The HTTP service then sends a get request using the specified URL. But what does this method now return? Since we are using strong typing, we should have a function return value here. The getProducts method returns an observable of response. Does this generic syntax look familiar? We used it earlier in this course to define the event payload when passing event information from a nested component to its container. Observables take advantage of generics to define the type of data it is observing in the observable sequence. In this case, it's the HTTP response. It's important to note that HTTP calls are single async operations, meaning that the observable sequence contains only one element, which is the HTTP response object. And we need to import response from the Angular HTTP package and observable from RxJS observable. But let's think about this return value for a moment. Do we really want an observable of response? Our components, such as the product list component, are expecting to receive a list of products, not an HTTP response. So we need to translate the response object to an array of products. We do that with the map operator. The map operator takes the raw HTTP response object returned from the HTTP get method and translates it into an array of products. The argument to the map method is an arrow function that transforms the response to a JSON object. We use a casting operator to cast the JSON object to an array of products. So now our getProducts returns an observable of iProductArray, which is much more useful for our components. Note that depending on your server, the JSON result may be wrapped in another property, such as a data property. If that is the case, use response.json.data here. To use the map operator, we need to load it using an import statement. Using the import statement like this is a bit unusual. It tells the module loader to load this library, but actually doesn't import anything. When a library is loaded, its JavaScript is executed, and for this particular library, executing the JavaScript loads the map operator. So this particular syntax imports the module for its side effects only, without actually importing any of its features. Now let's add HTTP to our product service. We are looking at our application's Angular module we called AppModule. Recall from the slides that Angular registers its HTTP service provider in an Angular module called HTTP module. In our application's Angular module, we import the HTTP module. This module is located in the Angular HTTP package. We then pull that module into our application by adding HTTP module to the imports array here. Now we can inject the Angular HTTP service into any class that needs it. Here is the product data service we created in the last module, with all of the hard-coded data. We want to modify our product service to get the product data using HTTP. Let's start at the top with the import statements. We import the HTTP client service and the HTTP response from Angular HTTP. We import observable from RxJS observable. And we import the map operator using this special syntax that loads the operator without actually importing anything. We want Angular to provide us an instance of the HTTP client service, so we identify it as a dependency in the constructor. We don't have a constructor yet, so let's add that first. Then we specify the parameter. Angular will then inject the HTTP client service instance into this variable. Now we need to identify the location of our web server. This doesn't look like a valid URL to a web server. To keep things simple, the demonstration reads the data from a local JSON file that was provided with the starter files. That way, we don't need to set up an actual web server. To change this code to work against a web server, simply change this URL to point to an appropriate web server. And of course, you need to write the server-side code to return the list of products. It's finally time to delete our hard-coded data. So let's delete the hard-coded products from the getProducts method. Gone. We'll call the HTTP GET method here instead, passing in the defined URL. When we get a response back, we use the map operator to map the HTTP response to a product array using response.json. We'll need to change the return type as well. Now this method returns an observable of iProductArray. We can't try this out at this point because we are not yet subscribing to the observable returned from this service. Let's add some exception handling first, then modify the product list component to subscribe to the observable list of products. As you can imagine, there are many things that can go wrong when communicating with a back-end service. Everything from an invalid request to a lost connection. So let's add some exception handling. We'll add a catch and pass it the name of an error handling method. The error handling method gets one parameter, the error response object. In that method, we can handle the error as appropriate. We can send the error information to remote logging infrastructure or throw an error to the calling code. And notice here one more thing. The observable has a do operator that allows us to peek at the data returned from the server without disrupting the flow. We can use this operator when debugging to log data to the console, for example. Notice we also need 2 more import statements, one for each additional operator we are using. Now let's add exception handling to our product service. This code is not really complete without the exception handling, so we'll add the appropriate imports and use the catch operator to call a local handle error method. In this method, we can log or handle errors any way we want. For our sample application, we simply log to the console and throw an error to the calling code. Let's also try out the do operator. The do operator lets us peek at the response data. We use json.stringify to display that data in a nicer format. So our getProducts method is complete. We can add other methods here to post or put data as well. We can't see the result of our hard work yet because we are not subscribing to this observable. Let's do that next. If you are familiar with promises, you know that you receive the result of the promise, X in this illustration, by calling then. Then takes two arguments, a value function that is called when the promise completes successfully, and an error function to handle any error condition. If we define X as an observable instead, we simply replace the then with subscribe. Since observables handle multiple values over time, the value function is called for each value the observable emits. In some cases, we want to know when the observable completes, so observables provide an optional third handler that is executed on completion. The subscribe function returns a subscription. We could use that subscription to call unsubscribe and cancel the subscription if needed. Now that our product data service is returning an observable, any class that needs product data, such as our product list component, can call our service and subscribe to the returned observable like this. As we stated earlier, observables are lazy. An observable doesn't start emitting values until subscribe is called. So this line of code calls the product data service getProducts method and kicks off the HTTP GET request. It is then set up to asynchronously receive data and notifications from the observable. The first function passed to the subscribe method specifies the action to take whenever the observable emits an item. The method parameter is that emitted item. Since HTTP calls are single async operations, only one item is emitted, which is the HTTP response object that was mapped to our product array in the service. So the parameter is our array of products. This code then sets the local products property to the returned array of products. The second function is executed if the observable fails. In this example, it sets a local error message variable to the returned error. A third function, not used here, specifies the action to take when the observable ends with a completed notification. The third function is rarely used when working with HTTP requests, since they automatically complete after emitting the single response. And we aren't using the return value here, since we have not provided an option for the user to cancel the request. Let's give this a try. Here in the product list component, we see a syntax error. Type observable of iProductArray is not assignable to iProductArray. Now that we've changed the product service to return an observable, we cannot assign the result to our product property directly. Rather, we subscribe to the returned observable. When the observable emits the data, we set our product property to the returned array of products. And since that product property is bound in the component's template, the retrieved data just appears in the view. But things don't always go as expected. To handle any errors, let's add an error message property. If our request for products fails, our error message property is set to the error. What is this any syntax? This is a casting operator. We are casting the error returned from the observable to the any data type. Are we ready to try it out? There are our products. Success! We have more products here now because we are retrieving the products from the provided product.json file. Sweet! Remember the do we added to the HTTP GET pipeline? It displays the retrieved data. If we open the F12 developer tools, we see that data in the console here. So the recommended way to use HTTP is to encapsulate it in a service, like our product service, then expose an observable for use by any class that needs product data. The class simply subscribes to the observable and waits for data or a notification. Let's finish up this module with some checklists we can use as we work with HTTP and observables. Before we can use Angular's HTTP client service, some setup is required. We need to ensure that the service provider is registered with the Angular injector. This registration is done for us in the HTTP module included in the Angular HTTP package. So all we need to do is pull the HTTP module into our application. We do this by adding HTTP module to the imports array of one of our application's Angular modules. Build a data access service to wrap HTTP requests. In that data service, specify the needed imports, define a dependency for the Angular HTTP client service using a constructor parameter. Create a method for each HTTP request. In the method, call the desired HTTP method, such as GET, and pass in the URL to the desired server. Use a map operator to transform the raw HTTP response to a JSON object, and do error handling as desired. In any class that needs data from a data service, call the subscribe method to subscribe to the observable. Provide a function to execute when the observable emits an item. This often assigns a property to the return JSON object, and if that property is bound to a template, the retrieved data appears in the view, and add an error function to handle any returned errors. This module was all about HTTP and observables. We began with an overview of observables and reactive extensions. We examined how to build a data access service that sends requests for data over HTTP. We walked through how to set up some basic exception handling, and we saw how to subscribe to the returned observable and ultimately display the resulting data in the view. We've now removed the hard-coded data from the product data service, yay, and instead retrieved the data using HTTP. In our sample application, we are using HTTP to retrieve the data from a local JSON file, but the techniques are the same for retrieving data from a backend service. Next up, we'll see how to display multiple pages with navigation and routing.